This is going to be my extra credit for test 4. I'll be splitting up the 4 questions into 4 different videos. So this is just going to be the first one. And I'm also only going to do one take, so excuse any of my errors or like mistakes. Oh my god. So you first need to find a functional group that contains an oxygen containing functional group, a nitrogen containing functional group, and other functioning functional group. So I think I found one right here, tyrosine. It's an amino acid, and I think it helps with producing proteins in your brain, like specifically. So let's first identify the functional groups. So usually you grab your functional group like table, and then you can find and try to find which functional group. So I'm just gonna identify the ones. This would be phenyl. This would be amide. And this would be a carbon. Excellent. I don't know how to say it. Carbon. Oops, misspelled that. Carbon-lac. And so this would be the oxygen containing functional group. This would be the nitrogen containing, and this would be the other. So you can just like identify them by using your table. Like for phenyl, you can see like in the middle column for examples, you can see like this exact shape, and you can also see the general formula on the left side. So you can identify them. So we're also supposed to find the find the hybridization, electrogeometry, and molecular geometry of all the atoms except the hydrogens. So let's just start with this OH here. Can I color code this? So this oxygen. Well, another thing you need to learn is bonding rules. So I'm going to write out a bonding rule table. This would be helpful when we start doing hybridization. So let's just write down common node and then bonding. I think it's bonding atoms. No, yeah, it's bonding atoms. So it'd be 1, 0, or hydrogen only needs 1 bond. Carbon would be 4, 0. In order, this is in order for it to have a full octet rule, to follow the octet rule. So you would need, and then you can start finding the hybridization and electrogeometry of all these. So I'll start this hydrogen here. Let's draw this out over here. So you'd see, like judging from our table, that oxygen would need 2 more lone pairs in order for it to fulfill the octet rule. So we need to remember to add those right here. So this is what the oxygen would actually look like. So using that, you can find the hydrogenation, electrogeometry, and the molecular geometry. So it's right there, right here. Oxygen. In order to find hybridization, you need to add bonding atoms. Make sure you remember it's bonding atoms, not bonding pairs. Like if there's a double bond, it still only counts for one bonding atom plus lone pairs. In this case, that would be 2 plus, because it's 2 bonding atoms and 2 lone pairs, so it would be 2 plus 2, which equals 4. And 4, you could use this finger trick where you draw a hand, S, P, B, SPP, and then you can count. So 1, 2, 3, 4 fingers. So hybridization should be SP3. 1S, 3 Ps, SP3. So next we need to find the electrode geometry, and you would use a linear table. Let me find mines. So if it has 2 lone pairs, or let's first identify how many electron groups there are. So electron groups is like a 1 lone pair of bonding atom. So there's 1, 2, 3, 4. If there's 4, then that means that it has a electron geometry of 109. Remember, electron geometry is the angle, and the molecular geometry is like the actual shape. So using your linear table, if it has two lone pairs and 2 bonding atoms, it'd be called bent. So you just repeat this process for the rest of the atoms. So let's just go through all the key ones. You should be able to get it, like, with practice, you should be able to get it pretty fast doing this. So let's go over this. Let's go over this oxygen right here, and let's draw it out. Should be oxygen, and there's a double bond here, so it's double bonded. Oh, not oxygen. Sorry if I mix up. It's carbon, and it has a double bond here, so carbon, 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 and this fills out the bonding rule. The bonding rules because it has 4 bonds, and then now it's right over here. I should probably choose a better color. So BA bonding atoms. You see, this is what I was talking about earlier. This will only count as 1 because it's bonding atoms, not bonds. Even though there's a double bond here, it's only 1 bond. So that would be 3 plus 0 because it's 0 lone pairs, which equals 3. With 3, do the fingers. 1, 2, 3, and they should be sp2 and BG. How many electron groups there are? There's 3 electron groups. 1, 2, 3. 1, 2, 3 means an angle 120. And the molecular geometry, if there's 3 atoms instead of like a lone pair, there'd be triangular planar. Next, let's do this nitrogen right here, and let's draw it out. So because it's 2 hydrogens here, then we know that it's also bonded to 2 hydrogens, and then it's also bonded to a carbon here. Remember that, like, if there's not an element there, like fall here, or all the joints, and you can assume that it's a carbon, because like organic chemists are lazy. And then in order for the bonding rule, or to fill out the octet rule, it needs to have 1 lone pair, so, and 3 bonding atoms. So we have 3 bonding atoms, so we just need to add the lone pairs. And now let's do the hybridization. I'll just do it up here. Yep, my bad. So BA plus LP are bonding atoms plus lone pairs. 1, 2, 3 bonding atoms plus 1 lone pair equals 4. And with the 4, then we do the finger trick. SP, P, 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 4. So SP3. And then electron geometry. It has 4 electron groups. 1, 2, 3, 4. 4 means it has an angle of 109.5. And molecular geometry has 1 lone pair, so using the Weber chart, we know that would mean a triangular pyramidal. Let's do a few more, and then remember for the test you have to do all of them, but for this video it would be like really long, and it's just like for these oxygen atoms mostly just be like repeating the same thing, so I'm just gonna do all the key ones for this video. You can take the time to do the rest of them on your own. So let's do this oxygen up here and groovy draw over here. So in order for it to fill out the bonding rules, we know they need to have 2 bonds and then 2 lone pairs. So we see the 2 bonds here, now we just need to put lone pairs. And then we can start writing the hybridization. Carbon. Oh, yeah, I should have chosen a better color again. My bad. Let's choose this red color. I'll just redraw this here so you know. Carbon, hybridization, Ba plus LP. Ba is one bonding atom plus 2 lone pairs. You see 2 lone pairs right here. 1, 2. So 3, finger trick. 1, 2, 3. So SP2. Molecular geometry is 120. And make sure you remember its angle. And molecular geometry, there's 2 lone pairs. So it'd be linear. It might not say on your Vesper chart, but like I mean, it doesn't say in the one I have, but if it doesn't, like if it continues one more, like if there's 2 lone pairs, I don't know how to describe it, but like if you go one step further in your table, then it should all be linear. And then let's do one more. Let's do I'll just do a black color. And let's do this oxygen right here. So we draw the oxygen. Now, you don't always have to redraw it once you get good enough, but just like redrawing it to so I can like fill out the bonding rules and make sure that I'm not messing anything up. And then you need since it has 2, you need that's oxygen. Since it has 2, you need to add 2 lone pairs. And we can start writing it out. Bonding pairs plus bonding atoms plus lone pairs. So it's 2 bonding atoms and 2 lone pairs, so that'd be 4. 4 is SP3. SP3, pressure geometry. Look at your Vesper chart. That would be 109.5. Pressure geometry. There's 2 lone pairs and 2 bonding atoms, so that would be bent. So you can do the rest. You can do the rest by yourself, but I'll just go through the steps one more time. So I like to take the atom, redraw it out, and then make sure you make it so it fills out the bonding rule. Like organic chemists are lazy, so they don't like drawing like the new stuff. So make sure you always make sure you added the stuff that they left out when you do the hybridization. And then you do bonding atoms plus lone pairs to find what SP is. SP, and then you do the finger thing to find what SP, and then the rest you just need like your Vesper chart and fill out. So that's question 1. I'll post the next questions, I think, in a comment underneath it. So thank you and have a nice day.